Alright, this is one of my favorite little clips of statistics, especially the early statistics, so pay, close attention to this. So when we talk about symmetry of the data and skew, and we think about what we just learned with the mean and the median, we can kind of see how these are related. Think about, for example, when you might have a mean and a median that are very different. The easiest example is with income, right? So in the US, we have some of the richest people in the world. If we were to take them out, we would have a much less skewed data. But with them in, it makes our mean really high. But the median, the more typical, the mid-range, is going to be much lower, right? It's going to be what the typical person makes, which is a lot closer to, I think it's 40,000, something around there. That's just off the top of my head, and I have no idea if that's accurate, but much lower than it would otherwise be, including the income of the billionaires. So, that means I'm going to skip the left skew and go to the right skew. This is what it would look like based on my example, right? We have outliers on the right that are making more than the mean, and they're pulling it up, even though the median is much closer to 7, 7.5, 8. And here we have the mean ends up being 7.7, median is 7.5, and that tells us that we're skewed to the right. If it was opposite, we would be skewed to the left. The other way to think about this is the direction of the tail is the direction of your skew.